Alright guys, so we want to prove that the area of an equilateral triangle is this expression where A is one of the sides. So really we're just trying to find the area of an equilateral triangle with respect to one of the sides. So let's draw a quick diagram here. So we start with an equilateral triangle. And let's go ahead and label these sides. We'll label them A, B, and C. And we're also going to let one of the sides be A. So when we start this quote-unquote proof, we're going to let triangle ABC be equilateral. And A be the length of one of the sides. We know because it's equilateral that if A is the length of one of the sides, then A is the length of all of the sides. We can go ahead and label that on our diagram. So the next step, the way that we can prove it a couple different ways. The first way that we can prove it is we can drop an altitude down and use the area formula. That's 1/2 the base times the height. Or we know Heron's formula gives us an area formula that's explicit to the sides of each of these triangles. So we're going to go ahead and use Heron's formula. So by Heron's formula, we know that the area is equal to the square root of S times S minus one of the sides times S minus the other side times S minus the third side. So there's our formula for Heron's, or for the area using Heron's formula. And because it's equilateral, all of our sides are going to be A. And we should probably define what S is in terms of the information that we know. So S is going to be all three sides added together, divided by 2, or the semi-perimeter. So S is equal to 3A over 2. Next step is let's plug in this expression for X. So substituting. We have that the area is equal to the square root of, and then S is 3A minus 2, so 3A over 2, and then just plug in for S up here. So we have 3A over 2 minus A, and that expression is actually cubed. So we have 3 of those. All right, simplifying here. So we've got our 3A over 2 times, we get a common denominator. So over here on the side, 3A over 2 minus A is going to equal 3A minus 2A over 2, which is just A over 2. So this is A over 2 cubed. Because there are 3 of these, we can pull one of those out in front. So we've got A over 2 times the square root of 3A over 2. We technically, we took 2 of these, took 2 of these out, so we have 1 left. So that's times A over 2. Simplify that, we get A over 2 times the square root of 3A squared over 4. And again, simplifying on the inside, we can pull out an A in the numerator. So that gives us A squared on the outside. Square root of 4 in the denominator, so that pulls out It allows us to pull out another 2 and gives us a 4 in the denominator. And then what's left on the inside is root 3. And there's our kind of informal proof. So if we want to kind of formalize the end here, therefore the area of an equilateral triangle is whatever one of the sides is squared over 4 times root 3.